Let's talk about angle relationships. Some angles are built off of opposite rays, which are just rays that have the same endpoint but head in opposite directions, like ray AR and ray AY in this diagram. Some angles are adjacent, like angle ABD and angle DBE, which means they share a vertex and a side. Some angles are non-adjacent, like angle ABD and angle EBC, which only share a vertex but no side. Some angles are complementary, which means their sum is 90 degrees. They might be adjacent, or they might be non-adjacent. Some angles are supplementary, which means their sum is 180 degrees. Again, they might be adjacent, or they might be non-adjacent. If they're adjacent, then we actually have a special name for them. We call them linear pairs. Linear pairs are adjacent angles whose non-common sides are opposite rays. So angle ABD and angle DBC in this diagram are a linear pair because they share side BD, and their non-common sides of BA and BC, they're opposite rays. And since those two angles are a linear pair, we know that they're supplementary. And we also have vertical angles, which are non-adjacent angles formed by the intersection of two lines, for example, angle EFI and angle HFG in this diagram. If two angles are vertical angles, then their measures are equal. There's always two pairs of vertical angles created by the intersection of two lines. We have the purple ones, and we also have these orange ones. And remember that each pair of purple and orange angles form a linear pair. So this one and this one are a linear pair, and this one and this one are a linear pair, and this one and this one are a linear pair, and this one and this one are a linear pair. So I want you to take a second and identify at least one of each of these types of angles or angle pairs in this diagram. Go ahead and pause the video and do it now. Let's see how you did. Vertical angles. There's actually a couple. Remember that there's always two pairs of vertical angles created by the intersection of two lines, and I see two full lines in this diagram. I see line UX and I see line YV. They intersect at point T. That means that they're going to create two pairs of vertical angles. The first pair I see are angle UTV and angle YTX. And I also see angle UTY and angle VTX. They're another pair of vertical angles. You might not have seen them as easily because these two angles have rays inside of them that create other angles. But if you look at the entire angle, the 90 and the 54 put together, that makes angle VTX, and the 108 and the 36 put together, angle UTY. If you add both of these pairs of numbers together, you'll get to the same answer of 144 degrees. Adjacent angles, there are a lot of them. So I'm not going to name every single pair of adjacent angles in this diagram. That would take forever. I'll just show you an example of what to look for. Angle UTV and angle VTW are adjacent. The reason is because they share vertex T, and more importantly, they share side TV. So since these two angles are basically touching or next to each other, that makes them adjacent. And keep in mind that adjacent angles, we don't really know anything about them other than the fact that they're next to each other. So it's not like complementary or supplementary or vertical that we know that they're 90 or 180 or they're equal. Adjacent angles is really just a description of where angles are in relationship to each other. It doesn't tell us anything about their measurements. Speaking of measurements, let's find some acute angles. Remember that acute angles are less than 90 degrees. So I see a few of them. I see this 36 degree angle, angle UTV. I see this 36 degree angle, YTX, and I see this 36 degree angle, angle ZTY. So obviously 36 and 36 and 36 are all less than 90, so that makes all of those acute. But it doesn't have to be 36 degrees in order to be acute. It could also be 54, for example. 54 is also less than 90, so angle XTW would be acute as well. And there's actually one more. If you combine these two 36 degree angles, it would be 72 degrees, and 72 is less than 90, so you could also say that angle ZTX is an acute angle as well. I see two right angles in this diagram. The most obvious one is angle VTW. It's labeled as being 90 degrees, and therefore it must be right. But there is another one. If you add 36 and 54, that adds up to 90 degrees, so you could say that angle YTW is also a right angle. Let's find some obtuse angles. There's only one on the diagram that is automatically obtuse, that you don't have to do any addition to figure it out, and that's angle UTZ. But that's by no means the only obtuse angle in this diagram. You could also say that angle UTW is obtuse, because 90 and 36 would obviously be bigger than 90, so that would have to be an obtuse angle. You could also say that angle ZTW is an obtuse angle, because 36 and 36 and 54 would be more than 90 degrees, and that makes it obtuse. There's actually a whole bunch of other obtuse angles in this diagram as well, but I think this kind of points you in the right direction. Let's talk about straight angles. I see a few of them. For example, angle VTY is straight. You can see that on the diagram because this is a straight line. These 3 points, VT and Y, are collinear. Or you could have also verified it by adding up these 3 angle measures, 36 and 36 and 108, would give you 180 degrees. You could also look at the other side of that and say that 90 and 54 and 36 adds up to 180 as well. Either side of that would count as a 180 degree angle. There is another straight angle in this diagram as well, angle UTX. Again, UT and X are collinear, so that means that this is a straight line or a straight angle, which adds up to 180 degrees. 36 and 90 and 54 is exactly 180. I see 2 pairs of opposite rays in this diagram. I see ray TV and ray TY. They both share endpoint T, but one heads up towards V and the other one heads down towards Y, so that makes them opposites. I also see ray TU and ray TX. They're another pair of opposite rays in this diagram. Again, they share endpoint T, but one heads off towards U, the other one heads off towards point X. Those 3 points are collinear, so that means that they are opposite rays. There's a few different pairs of complementary angles in this diagram. I think the most obvious one is the one that I have highlighted right now, which is angle WTX and angle YTX. Those 2 angles add up to 90 degrees. They happen to be adjacent, which is cool but not necessary, so that makes them complementary. But like I said, they don't have to be adjacent. I don't have to pick that 36 degree angle to add to that 54 degree angle. I could also pick this 36 degree angle. Even though those 2 angles are non-adjacent, they still add up to 90 degrees and therefore are complementary. And so are these 2. They also add up to 90 degrees and therefore are complementary. Let's talk about supplementary angles. For example, angle UTV and angle VTX. Those 2 angles add up to 180 degrees, therefore those are supplementary angles. You could also say that angle UTV and UTY are supplementary angles for the same reason. Or that angle UTZ and ZTX are supplementary, because they add up to 180 degrees as well. The first 3 examples I've shown you for supplementary all happen to be adjacent, but they don't have to be. You could also say that angle ZTY and angle VTX are supplementary. Even though they're non-adjacent, they still add up to 180, and therefore they're supplementary. I only see one angle that was bisected in this diagram, and that's the one I have highlighted in orange. It's called angle ZTX. I can tell that it's been bisected by ray TY because the angles created by that ray are equal to each other. They're both 36 degrees, which means that angle ZTX was cut in half by ray TY. Alright, so let's use all of this knowledge that we have about angle pair relationships to calculate all of the angles in this diagram one at a time. First, I want us to calculate the measure of angle EGD, this little angle right here, given that it is complementary with angle FGE, which measures 62 degrees. Remember that complementary means that they add up to 90, so if one of the angles is 62, I would need to subtract 62 from 90 to get to my answer. So the measure of angle EGD is 28 degrees, because 62 plus 28 is 90. You'll notice as we go through all of these that I'm going to be labeling my diagram with the information we just discovered. That's super important that you do that because a lot of these answers that we're going to find along the way are going to be built from other answers that we discovered earlier on. And without a labeled diagram, you'll be hard-pressed to figure it all out. So please, 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 label your diagrams. Next, I want us to calculate the measure of angle AGB. AGB is this little one right here. Do I see any kind of a relationship between this angle and the ones that I already know, these two angles right here? Well, yeah, these are intersecting lines. AD and BE are intersecting lines, and angle AGB and EGD are on opposite sides. They're non-adjacent angles created by the intersection of two lines. That means they're vertical angles. And vertical angles are always congruent, so that means that they'll both be 28 degrees. Okay, so what's the measure of angle AGF? AGF is this one right here. Well, it forms a linear pair with angle FGD, right? Because this is a straight line, or you can think about it as GD and GA are opposite rays. And angle AGF that we're trying to calculate shares side GF with angle FGD, which we could figure out the measure of angle FGD by just adding those two together. In fact, we already knew that it was 90, right? That's how we got to 28 on the first problem, because we were told it was complementary. We already knew that this was 90 degrees. So if this is 90 degrees, and these two angles, angle AGF and angle FGD, are supplementary, then doesn't AGF have to be 90 degrees as well? Because 90 plus 90 equals 180. Next up, we need to calculate the measure of angle BGC and CGD, the two missing angles in the diagram, given that GC is the angle bisector of BGD. Well, it would be easy to figure out those two angles if I knew the entire angle measure, right? If I knew BGD, I would just cut it in half to get to those two angle measures, because they have to be equal because GC bisected it. But we don't know the measure of angle BGD yet. Could we figure it out, though? I think we probably could, because doesn't angle BGD form a linear pair with angle AGB? Ray GA and ray GD are opposite rays, and angle BGD and angle AGB share side GB. That makes them a linear pair, which means they have to add up to 180 degrees. So the measure of angle BGD, this big obtuse angle right here, has to be 152. Okay, well, if I need to know the measures of each of these little angles, and GC is the angle bisector of the 152 degree angle, then I can just divide 152 in half. And I figure out that the measures of each of those angles are 76 degrees each. Alright, last but not least, let's incorporate some algebra with these angle pair relationships. We, again, are going to calculate all of the missing angle measures in this diagram based on what we see. The first thing I see is vertical angles. Right, I've got this line, SU, and this line, RT. They intersect each other. And this angle measurement, labeled as 8x degrees, and this angle measurement, labeled as 7x plus 9 degrees, those two would be vertical angles, right? Because they are non-adjacent angles formed by intersecting lines. So if these are vertical, then that means they're equal. So I can set 8x equal to 7x plus 9. All I would do is subtract 7x from 8x, and that just gives me a quick answer of x equals 9. Now you might be saying, well, wait a second, Mrs. Goforth, that's not what I saw. Could I do it a different way? Absolutely. You definitely might have seen that these two form a linear pair. Since QS and QU are opposite rays, and angle SQT and TQU share side QT, that makes the 14x minus 18 degrees angle and the 7x plus 9 degrees angle a linear pair. And since they're a linear pair, they must be supplementary, which means they add up to 180. So I would say 14x minus 18 plus 7x plus 9 equals 180, and then solve that all out. So I combine like terms, I added 9 over to the other side, and I divided by 21, and once again I got an answer of x equals 9. There is another way that you might have done it. You might have recognized that 8x and 14x minus 18, that those are a linear pair. So you might have added these two together and set it equal to 180, and guess what? You still would have gotten an answer of x equals 9. So once I know that the value of x is 9, I can plug it back in to figure out each of my angle measures. For example, angle SQR would be 8 times 9, which is 72. And angle TQU would be 72 as well, because 7 times 9 is 63, add 9 to that, I get 72. And I can also take 9 and plug it in for the measure of angle SQT. 14 times 9 minus 18 gives me an answer of 108 degrees. But there's still one angle missing in this diagram. I don't know the measure of angle RQV yet. Could I figure it out? Yeah, I think we could. Would you agree that the measure of angle RQU would be 108 degrees as well, right? We just figured out that the measure of angle SQT was 108. And angle RQU forms a vertical angle with angle SQT, so this whole thing would have to be 108 degrees. But I don't want the whole thing. I don't want RQU, I want RQV. Well, that's actually just the angle addition postulate at work. We have RQV plus VQU equals RQU. Fill in what we know. The measure of angle RQV is what I'm looking for. The measure of angle VQU was 18, and the measure of angle RQU was 108. So if I subtract 18 from both sides, I find out that the measure of angle RQV is 90 degrees. So it turns out that RQV is actually a right angle. Alright, that is all you need to know about all of those types of angle pair relationships, including complementary, supplementary, vertical angles, linear pairs, adjacent angles. You learned a lot in these past 3 videos. In our next video, we're actually moving on to a completely different subject, which is the midpoint formula.